Hello everyone, we are Group 4 and our project is Lean Llama, Balancing Compression and Performance. Just to draw some common ground, does anyone know how many A100 GPUs are required to run inference on the full GPT-4 model? 128. Do we really need this big a model for specific tasks or domains though? Not always. Can we always afford to deploy such large models? Of course not. So how do we tackle such monsters? Some methods are pruning, quantization, distillation, and maybe a combination of these.
Pruning helps simplify models by trimming less important connections, resulting in leaner networks without costly retraining. Quantization, on the other hand, lowers computational precision, converting heavyweight floating point numbers to lighter integers, saving considerable memory. By integrating these two techniques, we aim to maintain accuracy while drastically improving deployment efficiency. The challenge with models like Llama 2, which has 7 billion parameters, is deploying them in real time scenarios. To solve this, we experimented with pruning, specifically Wanda and Sparse GPT models, to remove up to 70% of the unnecessary critical but least critical weights. We paired this with quantization, converting models to 4-bit and 8-bit precision. The core question guiding our research was how can we most effectively combine these strategies to get the best balance of size and performance?
Our workflow involved an experimentation process aimed at evaluating the trade-offs between model compression, accuracy, and inference efficiency. We applied pruning techniques like Wanda and sparsity at varying sparsity levels to investigate their impact on model performance. In parallel, we also employed quantization using bits and bytes, reducing model precision to 4-bit and 8-bit formats to further optimize for memory. And finally, coming to the evaluation part, we used eLuther AI's evaluation harness to test each configuration on 4 diverse benchmark tasks that are ANLI, Common Sense QA, Pika, and we know gender. Now that we have outlined our experimental setup and our evaluation methodology, I'll walk you through the actual workflow. So we began with a pre-trained Llama model, which served as the input to our two-stage optimization process, pruning followed by quantization. In pruning stage, we experimented with two techniques that are Wanda and sparsity. We also included a no pruning baseline to assess the impact of pruning alone. Following pruning, we applied quantization using bits and bytes. The output of this two-step process is a lighter model which is optimized for efficiency while preserving as much accuracy as possible. This pipeline allowed us to systematically evaluate each combination of techniques and models' performance across our benchmark tasks. Passing it off to Dhruv.
Okay, now let's analyze the current results. We will start by looking at the impact of quantization only. For this analysis, the plot shows different quantization results on the vanilla llama model. Quantization in general exacerbated the results, and surprisingly, it also slowed down inference despite improving memory efficiency. Our current hypothesis is that this happened due to using A6000s instead of GPUs that are optimized for 4-bit and 8-bit models. Next, we will look at the impact of different pruning techniques. In general, sparse GPT outperformed Wanda, but is slower and uses a lot more memory. Our most interesting finding from this was that pruned models not only maintained accuracy, but sometimes slightly outperformed the original model. Like Wanda 50% improved performance over Vanilla Llama and Wanda 30% while being faster and using less memory. Finally, we analyzed the performance of both quantization and pruning techniques together. In this analysis, we saw sparse GPT 30% model gives the best performance. Wanda 50% 4-bit model seems to be the most memory efficient with decent performance. Wanda 50% model is the fastest. In general, quantization had a large impact on memory efficiency and inference speed, but the impact on inference speed was negative, while pruning had a positive impact on inference speed and was able to retain most of the performance.
For some key takeaways now, model compression via pruning and quantization generally preserves performance on most benchmark tasks while significantly reducing memory requirements. Wanda pruned Llama at 30% sparsity maintains comparable performance to vanilla Llama across most benchmarks. Sparse GPT pruning at 30% with 8-bit quantization actually showed surprisingly good results on Pika, suggesting that this pruning technique might actually enhance certain reasoning capabilities. Inference speeds show inconsistent patterns. Pruned models are sometimes faster than vanilla, but quantization generally slows down inference. Thank you.